Stop that. All right, so I have a colleague who is interested in rocking something backwards and forwards. Could be a baby, not really sure actually. But the requirements are that the object, which is cylindrical, is in a harness like that, and that's obviously suspended. And then what he's thinking is that there's let's say a 12-volt motor here, and there'll be some sort of arm which extends and just moves this across. So maybe it goes in an arc of 90 degrees or so, and comes across, rocking that object, could be a baby, probably isn't, backwards and forwards. And then when it settles down, this returns to its original position, which moves obviously past this cylinder again and rocks it in its cradle again. And maybe that happens, every 5 minutes or so. So it's a bit of a constant motion happening. So that's the plan. Now, to do that, probably the 12-volt motor would have to be hooked up to some sort of motor controller, maybe some sort of MOSFET motor controller. I'm thinking that there's probably got to be some sort of flyback diode in here as well, and then maybe the information from here comes from a microcontroller. So we could use, for instance, this guy. So this looks like an Arduino Uno, but in fact, what we've got here is an ATmega88 chip that's in there. So this is one of the recovered ones from a recent video, which I will link in. So to get some use out of it, this project seems perfect. And then I found this in the buckets. So this is an L298 motor controller. And what it's got is it's got 12 volts coming in, ground, 5 volts going out, which can actually power the Uno, and then the ability to run a left and a right motor. And of course, there'll only be one of those required for something like this, which is a 12-volt motor. Now, in fact, probably in the final version, because this object is quite large, this will probably need to be something like maybe a 12-volt motor, wiper motor from an automobile. Yeah, we'll get one of those. But just proof of concept before that, I've got some code to put on here, which will, via the motor controller, control the motor to do that motion. So let's wire it up and see if we can't get some rocking action happening. Okay, so will the motor work to start with? So I've got 10 volts. I think I've got current limiting at around 0.8 or 0.9 amps. So we'll just see if the motor's actually going to work. I'd say yes. Switching current supply here at 12 volts. No, actually less. I think around the 11 mark. And then that supplies the L298 module. And the yellow here is the 5 volts coming out from that module. And then you've got the common ground. And you've also got coming out from the motor controller here, going to your 12-volt motor, and then some pins here to the control pins for this module here. So first thing to do is to see if we're getting anything at all. Well, yes, some pretty interesting rocking. I'm guessing that that's probably got something to do with the amount of time and the timing of the chip. So I'm going to go back and burn some fuses and have a little go, but at least it's moving. So that's not such a bad result. Let's push on. Two problems that came up. One easier to solve than the other. The first one was that this thing doesn't have any gearing. So in order to run this at slow speed, I was having to actually take out the little jumper here, which enables the whole thing to run at 12 volts, run it a bit higher, but then use PWM to change the voltage, run the Arduino off a separate power supply. It was getting very messy, all because basically this isn't geared. The other problem is that at a lower voltage, or when PWM is used, to overcome the friction to start the motor in the first place was problematic. And it didn't occur to me how to fix this until I was shifting some wood in a wheelbarrow and realised that I had to put a lot of effort to get the wheelbarrow running, but when it was rolling it was fine. So the actual code for this, and I'll put it up here so you can see, the actual code for this has a little bit at the start where it's basically full power for 20 microseconds. Then it drops down to about 2/3 of that for 10 microseconds, and then it has the PWM going down to, I think it's something like 25 is the out of 250, which is what the eventual speed was. I mean, the other way to get around it would be to have a motor not unlike this that's geared even slower. So yeah, that's basically what's required. A little bit of a push to get it going, and then a slower speed in the middle, and then it's actually completely off at its end. So now I think I'm in a position to be able to test it with this smaller motor. If only I could maybe think of something which is in a cradle or a harness that might be able to be pushed around. Okay, let's give that a try. And that's the circuit working for this week. See you next time.